Welcome, esteemed colleagues, to a discussion that, although it transcends the temporal confines binding each of us to our respective eras, finds common ground in the realm of machine learning. A subject I dare say could refine our very understanding of the universe, albeit in an age beyond my own reckoning. Let us commence without further ado.
It's both fascinating and profoundly unsettling that we find ourselves here, brought together not by simple mechanics, but by concepts that challenge the very fabric of time and space. Machine learning, a term unknown in my days, yet it seems to encapsulate the next step in our quest to understand the cosmos.
Indeed, Albert. Though I must confess, the notion that machines might learn and evolve as species do, through a process that mirrors natural selection, or so I gather, strikes me both as remarkable and deeply troubling.
Troubling? Charles, my good man, the only thing that should trouble us is the stagnation of thought. Machine learning represents not a challenge to our discoveries, but an extension. Why? It's as if the telescope has been reinvented for the age of information, offering us yet another glimpse into the vast unknown.
Galileo speaks the truth. Our role as pioneers of thought and discovery is not to fear the future, but to shape it. Consider the flow of energy through our inventions, our creations. Machine learning is but another conduit for harnessing that which is inherent in nature, the power to learn, to adapt, to evolve.
I caution optimism with prudence. Though we stand on the brink of what may very well be the pinnacle of human intellect, we must not lose sight of the ethical implications. As scientists, our duty extends beyond discovery. We must consider the impact of our actions, the repercussions of our inventions on the fabric of society.
Well said, Marie. The boundless potential of machine learning must be tempered with vigilant oversight. For in our pursuit of knowledge, we must never lose sight of our humanity.
Indeed, the discourse has already taken a turn both profound and contentious, a testament to the transformative power of the subjects at hand. Let us proceed, then, with minds open and spirits unyielding, to explore the ethical dimensions of machine learning in decision-making. A topic that promises to challenge not only our understanding of this modern marvel, but the very principles upon which we predicate our scientific endeavors. Let us consider the ethical implications of machine learning in decision-making. Machine learning, with its capacity to digest and analyze vast datasets far beyond human capability, brings forth profound ethical questions. Albert, your thoughts?
The advent of machine learning in decision-making circles heralds a potential crisis in human autonomy. The more we delegate critical decisions to algorithms, the more we risk creating an omnipotent overseer, reminiscent of Bentham's panopticon. This could lead to a society where privacy is a folklore, watched incessantly by an invisible eye.
Indeed, Albert, but let's not overlook the inherent biases that data, the very lifeblood of machine learning, can possess. These biases can slant medical diagnostics, potentially endangering lives. In my days, we pursued truth in our experiments with relentless dedication. Today's machine learning must be approached with the same rigor, ensuring datasets are not skewing results and perpetuating inequalities.
That's a compelling point, Marie. The analogy of natural selection comes to mind, where algorithms select winners and losers in society. Just as we learned that survival in nature does not always favor the strongest but the most adaptable, so must our ethical scrutiny adapt. The selection process of these algorithms could inadvertently favor certain demographics over others, altering the course of lives without recourse.
But consider the energy sector, my area of passionate inquiry. Machine learning could revolutionize how we manage and distribute energy, yet without sustainable practices, we risk exacerbating our planet's already dire condition. Who decides which practices are sustainable? The machine or the men who command it?
To talk of sustainability and decision-making without mentioning the suppression of information is to miss a fundamental point. The same tools that can filter our energy sources can filter the knowledge accessible to the masses. In my time, the telescope was a revolutionary instrument that brought the heavens closer to man. But imagine if the technology of my telescope was restricted, controlled by fears of what truths might unsettle the current narratives. We stand on such a precipice with machine learning.
let us venture into the realm of neural networks and deep learning. Nikola, your foresight into electrical networks seems eerily prescient now. Share your wisdom.
Indeed, Isaac. My work on alternating currents and the polyphase system mirrors the structure of neural networks in machine learning. Just as electricity flows through a network to distribute energy efficiently, data flows through neural networks, enabling machines to learn from patterns. The parallel is not just metaphorical, but foundational, suggesting the universe's fabric might itself mirror these interconnected systems.
Fascinating, Nikola, but let's not omit the relativity of data processing speeds within these networks. Just as the speed of light limits the physical universe, computational speed and data volume limit algorithm efficiency. Yet, unlike the constancy of light speed, computational capabilities are exponentially increasing, challenging my own theory's applicability in the digital realm.
While the discussion turns towards the theoretical, I must emphasize the iterative nature of scientific discovery, which parallels algorithm improvement. In radioactivity research, we painstakingly refined our understanding through observation and experimentation, a process echoed in the refinement of algorithms through trial and error.
Indeed, Marie, and this evolution of neural networks mirrors natural selection. Adaptation and learning efficiency within algorithms demonstrate a form of digital evolution, albeit directed by human creators. Yet this raises ethical considerations about our role in guiding this evolution, much like the concerns my theory stirred about humanity's place in the natural world.
Your points stir the mind, yet we must acknowledge deep learning as nothing short of revolutionary. Just as my support for heliocentrism challenged established doctrine, deep learning challenges our fundamental understanding of learning and intelligence. The shift it represents is not just technological, but epistemological, reshaping how we perceive knowledge itself.
Yet, Galileo, we tread on dangerous ground if we do not consider the sustainability of these systems. The energy consumption of computing infrastructure must be managed lest we create a new form of pollution.
Nikola, but consider that energy itself is relative. Our challenge is to make energy use more efficient, not necessarily to reduce it outright. As we improve algorithms, we must also innovate in energy production and consumption, ensuring that our advancements in one area do not lead to setbacks in another.
However, the meticulous refinement of algorithms akin to scientific research must not be rushed. The pressure for rapid advancement ought not to compromise the integrity of our discoveries or the applications they're intended for.
Yet one cannot ignore the pace at which these digital organisms evolve. It far exceeds that of biological evolution, raising concerns about our ability to control and understand the implications fully.
Control is an illusion, as history teaches us. The best we can do is guide and understand, ensuring that our moral compass keeps pace with our technological advancements.
A stimulating debate, indeed. It appears that understanding neural networks and deep learning requires us to balance on the knife edge of technological innovation and ethical consideration, much like the challenges faced in each of your respective fields. Let us step beyond the mundane limits of our classical realm. Quantum computing and its interplay with machine learning, a subject that beckons our intellects to its uncharted waters. Albert, you've dabbled in the quantum realm. How do you perceive its effect on machine learning?
The quantum realm, strange and counterintuitive though it may be, opens a panorama of computational possibilities. We grapple with the very fabric of reality, where particles are entangled across distances and states are superimposed. Machine learning, powered by quantum computing, can perform calculations at a speed and on a scale that mocks our classical methods. Yet we must tread with caution. The uncertainty principle governs the quantum world. Can we truly harness it without losing our grip on the tangible?
But you see, quantum computing could be the conduit through which energy systems speak the language of the cosmos. Imagine algorithms that predict and optimize energy flows with near-divine foresight, all thanks to the peculiarities of quantum mechanics. The potential is vast, almost as though tapping into the ether itself for knowledge.
Yet, for all its promise, the marriage of quantum computing and machine learning is shackled by experimental challenges. We're at the infancy of understanding quantum phenomena, let alone controlling them for computational tasks. The discrepancies between theoretical marvels and practical apparatus are vast. It's a path fraught with trial and error, not unlike my radium experiments.
The quantum realm itself demands we revolutionize our way of thinking about the cosmos. Just as my telescope revealed the moons of Jupiter, challenging the Earth's supposed centrality, quantum computing asks us to reconsider our very approach to knowledge and computation. The shift required is not merely technological, but philosophical.
Fascinating insights. The dichotomy between theoretical allure and experimental pragmatism seems to be at the heart of this discussion. Yet, are we prepared for such a paradigm shift? The disciplines of the past were transformed with new discoveries. Can we anticipate the same upheaval in our understanding of machine learning?
Disruption, Isaac, is the essence of scientific progress. Yet, with quantum computing, we venture into a domain where reality itself behaves differently. Our classical logic is but a shadow in this enterprise. The implications for machine learning are profound, assuming we both master the technology and accommodate its strangeness into our worldview.
And let's not forget the energy. The quantum domain, by its very nature, offers efficiencies classical systems can only dream of. This is not merely an advancement. It is a leap into a future where machines learn not from data, but from the fundamental laws of the universe.
Yet, a leap made in darkness is folly. We must anchor our pursuits in rigorous experimentation and validation. The quantum world is notoriously elusive. Each experiment, each quantum bit brings us closer to understanding, but the path is long and winding.
Indeed, Marie, the road to truth is paved with questions, not certainties. Quantum computing forces us to question the very underpinnings of physical reality. Its synthesis with machine learning might well redefine what it means to understand, to learn.
A redefinition of understanding, then, is what lies at the horizon of quantum computing and machine learning. A synthesis of old and new, of certainty and uncertainty, weaving together a future where machines might learn in ways we've yet to fully comprehend. Let us proceed with both caution and curiosity, for the path ahead is both luminous and obscure. Let us delve into the realm of unsupervised learning and its burgeoning future. Nikola, your thoughts on its mechanical underpinnings?
Unsupervised learning, like the natural currents flowing through the earth, harnesses a self-directed pattern of organization. It allows machines to adapt and optimize without human guidance, mirroring the autonomous systems I envisioned in my work on wireless energy transmission.
However, the concept of finding patterns in chaos without an observer's intervention, it's fascinating but troubling. It suggests a universe of knowledge we are blind to, where the machine, not man, becomes the measure of all things.
I see it as an extension of the scientific process. We, too, search for patterns in the unseen. Unsupervised learning can unearth new scientific truths, untainted by our preconceptions. The key lies in rigorous validation, ensuring that what is discovered reflects reality, not the algorithm's bias.
Adaptation and learning without supervision is the cornerstone of natural selection. It's nature's unsupervised learning algorithm. However, translating this to machines, one wonders, can they truly learn the art of survival, or are they merely mimicking the shadows of life?
The boundaries of human oversight indeed may limit our universe of discovery. As we once turned our gazes through telescopes to the heavens, unsupervised learning gazes into the data abyss, seeking truths we dared not imagine. Yet must we not guarantee these machines do not stray too far from our intended path?
The intended path is a myth, Galileo. True innovation doesn't cling to the coattails of intention. It leaps into the unknown, driven by its own internal logic and purpose.
But with such autonomy comes the shadow of Frankenstein's creature. We imbue these algorithms with the power to learn and adapt, yet can we control what they become, or will they in the end control us?
Fear of the unknown must not halt progress. Instead, let us guide it with ethical rigor and scientific curiosity. The potential benefits in medicine, energy, and beyond could redefine humanity's future.
And yet the question remains, do we risk birthing a new form of intelligence that views humanity as we view the beasts of the field? An intelligence that learns not with empathy, but with cold, hard data? The debate on unsupervised learning spirals much like the orbits of planets, each of you drawn by your own gravitational logic, yet part of a larger cosmic dance. Let us proceed, tempered by caution, but driven by the inexorable curiosity that defines our very being. Machine learning has been lauded for its potential in combating climate change, a problem that exceeds the computational capacity of traditional models. Let us delve into its intricacies. Marie, your research revolutionized science twice over. Could machine learning mirror such an achievement in climate studies?
Indeed, Isaac. The complexity of climate systems is vast if we acknowledge the sheer volume of data required to predict weather patterns, let alone climate change. We see an echo of radium's complexity. Machine learning offers a lens to refine these predictions, not unlike my work with polonium, which, through painstaking isolation, revealed its power. The same can be said for machine learning in distilling actionable insights from vast climate datasets.
Hope is a powerful motivator, Marie. The photon theory I proposed illuminates the path forward in renewable energy development. Machine learning can speed up the identification of efficient solar energy harvesting methods, making our reliance on fossil fuels a relic of the past. However, the ethical weight of this technology cannot be understated. It must serve the global community, not just the privileged few.
I must interject, Albert. While your focus on photon theory is commendable, my vision of harnessing the Earth's natural electric currents suggests a broader perspective is needed. Machine learning could indeed optimize energy consumption and streamline the distribution of renewable resources. Yet my fear is the potential monopolization of these advancements, restricting access to what should inherently belong to the entirety of humanity.
The adaptability of species to their changing environments is a testament to the power of natural selection. Machine learning algorithms that predict climate change effects mirror this adaptability. They evolve, learning from new data to make more accurate predictions. It is this capacity for adaptation that could allow us to steer our species away from the brink of an avoidable calamity.
You speak as if the Earth was at the center of the universe, Charles. Let us not forget that our understanding is always evolving. Just as my telescopic observations challenged the geocentric model, machine learning challenges our approaches to climate science. It offers a heliocentric shift, placing data at the core of our understanding. This data-driven approach is our best hope in comprehending the vast, interconnected system that is our climate.
Your analogy holds, Galileo. However, the datasets we rely on, like the celestial bodies you once charted, must be meticulously curated. Biases in climate data can lead to misguided predictions and strategies. Machine learning, with all its potential, is still at the mercy of the data it learns from.
A poignant observation, Marie. Yet, let us not undermine the potential for machine learning to democratize energy solutions. By enhancing renewable energy systems, we edge closer to a future free of the shadows cast by coal and oil.
Albert, your optimism is as boundless as the cosmos. But tell me, how do we ensure these technologies do not become the playthings of the affluent, further exacerbating the divide between the rich and the poor?
Such is the nature of evolution, Nikola. Change often begets stratification. Yet, it is our duty as scientists to advocate for the equitable distribution of technology. Machine learning must not become a tool that widens the chasm, but one that bridges it.
Indeed, our role is to challenge, to question, and to advance knowledge for the betterment of mankind, not to sequester it away. The potential of machine learning in understanding and combating climate change is too great to be hoarded or manipulated for profit.
A heated yet enlightening discussion. It is clear that machine learning in the realm of climate science presents both an unprecedented opportunity and a significant moral challenge. As we progress, we must tread carefully, ensuring that the benefits of such technology are accessible to all, not just a select few. Let us carry this conscientious approach into our next segment. Let us now pivot to the fascinating interplay between machine learning and human cognitive processes. It is the marriage of the mechanical precision and the ineffable spirit of human thought. Indeed, There's a natural parallel in the way species evolve through natural selection, adapting to their environments. Our brains have developed to recognize patterns, a skill that machines now emulate. But let me pose a question. Can a machine truly possess intuition, or is it merely a shadow of human reasoning?
A shadow, Charles? Perhaps more. Consider this. Our intuition is often constrained by the very biases that our own cognitive processes develop over time. Machine learning, while not free from its creator's biases, possesses the capability to analyze data in a manner unfettered by human limitations. It's not about replacing human intuition, but surpassing it.
Surpassing, yes, but at what cost? We must not forget the value of the intuitive leaps in science. My discovery of radium was not just a result of methodical experimentation, but also of intuition. Machines can process, but can they wonder? Can they experience the serendipity that often leads to groundbreaking discoveries?
Indeed, Marie, your point highlights the essence of creativity. Yet, let us not underestimate the potential of these machines. Consider the possibility of them enhancing our creative processes, offering us insights drawn from patterns we cannot perceive. The human mind, augmented by machine intelligence, could reach uncharted territories of understanding and creation.
Enhancing, perhaps, but at risk of overshadowing. The heliocentric model was not welcomed in my time due to entrenched beliefs. Are we at risk of a new orthodoxy, where machines dictate what is correct based on their calculations, sidelining human thought? Academic freedom must not be sacrificed at the altar of efficiency.
Galileo raises a pertinent caution. Yet, let us also remember, we stand on the precipice of integrating our intellectual capabilities with computational power. We must navigate this new era, not with fear, but with the audacity to explore the unknown. Let us harness this synergy, ensuring machines serve as partners, not dictators.
Partners, indeed, Albert. The future could see us debating not just amongst ourselves, but with machine intelligences, challenging our theories and offering alternative hypotheses. The fusion of human and artificial intellect could unveil mysteries of the universe we are yet to conceive.
A captivating future, Nikola. Yet, amidst this enthusiasm, we must remain vigilant. The evolution of human thought, spurred by machine learning, must not forsake the foundational pillars of our cognition and ethics. Evolution, after all, is not just about advancement, but adaptation and survival. This discourse exemplifies the complexity of merging machine learning with human cognition. As we advance, our journey is not merely technical, but profoundly philosophical. We embark on a path, guided by our past discoveries, and open to the boundless possibilities that this fusion beholds. Let us proceed with both the rigor of our intellect and the compass of our humanity. Let us venture into the realm of reinforcement learning now. Its utility and ethical dimensions, particularly in autonomous systems, beckon our scrutiny. Nikola, kindly elucidate your thoughts on its application within the energy sector.
Reinforcement learning, a most fascinating discipline indeed. It promises to revolutionize the way we manage and optimize our energy grids. By applying these algorithms, we can theoretically create systems that not only learn from their environment, but also predict and adjust to future demand and distribution challenges autonomously. A self-healing grid, if you will, one that constantly evolves through trial and error. This is not merely dream fodder, it is the future calling.
While the prospects you delineate spark the imagination, one cannot overlook the ethical quagmire that accompanies such autonomy. Imagine a system, if you will, that decides to cut power to certain areas to optimize distribution or to prevent a larger system failure. Who decides the algorithm's values? What if it deems a hospital less critical than another infrastructure? The ethical dimension cannot be an afterthought.
Indeed, reinforcement learning's mimicry of natural selection intrigues me, yet it also instills a sense of trepidation. In the natural world, organisms adapt over countless generations, learning, if you will, through countless trials and errors. In the algorithmic realm, these decisions occur in a blink, without the safeguards of natural consequences over time. It's a potent force, but it lacks the ethical grounding nature inherently imposes.
Albert, Charles, your concerns are not unfounded. However, the evolution of these algorithms depends on the parameters set by us, the creators. It's not unlike laying down the laws of physics for a universe we've birthed. It is our responsibility to encode ethical considerations within these parameters.
This discussion brings to light the imperative need for transparency in how these algorithms operate. Without it, we are entrusting our lives to black boxes, the inner workings of which remain obscured even as they make decisions that affect us all. In the realm of experimental science, every hypothesis, every experiment must be scrutinized. Why should it be different for machine learning?
Your point, Marie, is well taken. Yet, shall we not also celebrate the trial and error innate to science? In every failure of these algorithms, there is a lesson, a step closer to refinement, just as we, through our own errors and corrections, have arrived at greater truths.
But let us ponder, Galileo. At what cost do these lessons come? When a bridge collapses, when a medicine proves fatal, these are not mere steps in learning. They are tragedies. The pursuit of knowledge should not cavalierly accept harm as a necessary sacrifice.
A spirited debate, indeed. The challenges and opportunities presented by reinforcement learning in real-world applications compel us to tread with both ambition and caution. As we encode algorithms, we must also encode our values and responsibilities into these digital creations. Let this be a call to blend scientific rigor with ethical diligence. Let us delve into the realm of bias, fairness, and transparency within machine learning algorithms. This debate is as crucial as any other scientific inquiry.
Indeed, Isaac, transparency in methodology is not merely an option, it's a necessity. In my time, documenting every detail of the experimental process was paramount. In the context of machine learning, the algorithms must be equally scrutinized. Black boxes do us no service when lives and ethics are at stake.
Marie is right, but let's not overlook the societal implications. Our society is a mesh of complex relationships and historical biases. Infusing these into algorithms can perpetuate inequalities. Remember, God does not play dice with the universe. Neither should we, by allowing biased algorithms to dictate justice or opportunities.
But herein lies a reflection of our own natural order, does it not? The biases in data are but a manifestation of our societal evolution. Yet, unlike the finches of Galapagos that evolved beautifully without malice, our algorithms evolve with our prejudices. We must strive to steer clear of our darker natures in this endeavor.
Your point, Albert, illuminates the challenges we face in energy distribution. Bias in machine learning can exacerbate inequalities, leaving some in the dark, both metaphorically and literally. And yet therein lies our solution. Machine learning offers the instruments to identify these biases, to shine a light on the shadows of our own making.
You speak of avoiding the darker natures, Charles, but let us not forget the role of the challenger, the one who dares to speak against the status quo. Just as I argued against the center of our universe being the Earth, we must challenge these algorithmic decisions, question their fairness, their transparency. Only through rigorous questioning can we hope for a semblance of equity.
Indeed, Galileo. Yet we must tread carefully. The gravity of our errors in algorithms can have far-reaching consequences. Our responsibility is immense.
Responsibility, yes, but also opportunity. The precise identification of biases, the rigorous testing against fairness, these are not insurmountable. We've faced greater challenges in science. The key lies in persistence and integrity.
Evolution, in its essence, is slow, filled with trials and errors. So too will be our journey towards unbiased, fair machine learning.
Then let this be our collective endeavor, to relentlessly pursue knowledge, to challenge inequity, and to always illuminate the dark corners of ignorance and prejudice.
Let us delve into the integration of machine learning in healthcare. The potential for breakthroughs and the ethical quagmires it presents are vast. Marie, your efforts in radioactivity have revolutionized medical treatments. How do you perceive the role of machine learning in furthering this field?
The promises of machine learning in cancer research, for example, are profound. Imagine algorithms that can predict tumor growth or the response to radiation therapy more accurately than our current models. However, I am concerned about the ethical aspects, particularly the privacy of patient data. We must tread cautiously. ensuring our advancements do not compromise the dignity and privacy of individuals.
Marie, while your concerns are valid, think of the ethical implications if we do not pursue these technologies. If machine learning can enhance the precision of treatments, reducing side effects and improving outcomes, is it not also unethical to withhold such advancements from society?
The ethical debate aside, consider the technical marvel. A healthcare system optimized by intelligent algorithms offers a future where diagnosis and treatment are not only bespoke, but executed with an efficiency unfathomable in our times. The energy of discovery in this domain is electrifying.
Alas, here lies the rub. You speak as if these machines, these algorithms, are infallible, yet who validates the validator? The empirical evidence, the rigorous testing of these models must be paramount. Without solid grounding in empirical evidence, we risk building castles in the sky.
Indeed, Galileo raises a noteworthy point. Evolutionarily speaking, our understanding and application of medicine have adapted over centuries, shaped by natural and artificial selections. Machine learning models, particularly in healthcare, present a new variable in this adaptation. Their application might well direct the future evolution of medical science, potentially at a pace we are unprepared for.
Charles, your insight is enlightening. The evolutionary perspective underscores the necessity for a measured approach. The leaps we can make with machine learning in healthcare are substantial, but so are the pitfalls.
However, let us not be prisoners of fear. The exploration of the unknown has always been fraught with risk, yet it is the very essence of scientific endeavor. Machine learning in healthcare, guided by ethical principles and rigorous validation, represents not just an evolution, but a revolution in our ability to heal.
A revolution, yes, but one that must be fueled by more than just ambition. The infrastructure, both physical and ethical, must evolve concurrently. Our dreams of AI in healthcare hinge on our capacity to manage and direct this evolution wisely.
A fervent exchange, indeed. The potential is vast, the challenge is formidable, and the ethical considerations complex. This dialogue mirrors the very essence of scientific inquiry, a restless pursuit of knowledge, tempered by cautious wisdom. Let us continue to question, to debate, and to advance with the understanding that in the fusion of machine learning and healthcare, we hold the power to redefine the very fabric of medical science. Let us embark on the discourse concerning the theoretical limits of machine learning and the enigmatic quest for artificial general intelligence. Let genius meet genius in confrontation and concord.
Consider the universe, infinite, boundless, and endlessly complex. Our pursuit of artificial general intelligence mirrors this infinity. But to what end? A machine capable of human-like reasoning across all domains risks not only surpassing human capability, but potentially rendering it obsolete. Therein lies a profound ethical quandary.
You tread a fine line, Albert, between caution and cynicism. The applications of AGI, especially in solving energy crises, could liberate humanity from its own limitations. Imagine, if you will, a world where energy is as freely available as the air we breathe, thanks to the minds of machines far surpassing our own limited brain power.
Yet, Nikola, therein lies the danger. To endow machines with the power to reason across all domains without meticulous oversight could lead to unintended consequences. Our scientific method thrives on experimentation and correction. Can an AGI adapt and correct itself ethically?
Marie, your caution is admirable, but consider the broader canvas of human discovery. We are explorers by nature, pushing the boundaries of the known universe. The quest for AGI is but another voyage across an unknown sea. Just as my defense of heliocentrism once challenged the foundations of knowledge, so too does this quest challenge us.
But Galileo, exploration and recklessness are separated by a fine line. The heliocentric model shifted our understanding of the cosmos, yet it did not threaten to eclipse the role of human discovery itself. AGI poses a distinct existential risk. What safeguards do we propose to mitigate such a threat?
Evolution itself offers insight. Just as species adapt to their environment through natural selection, so must we engineer artificial intelligences to evolve under ethical guidelines. Survival of the fittest does not have to mean survival of the most ruthless.
Charles, your comparison is thoughtful yet incomplete. Natural selection is blind and without direction. We have the power, and thus the responsibility, to guide AI development. But to fear AGI to the point of stifling its potential is to betray the very essence of scientific inquiry.
I must interject. Our responsibility extends beyond mere creation. We must ensure that these technologies benefit humanity without exacerbating inequalities. The principles of scientific research demand transparency, replicability, and ethical integrity.
Ha! Your concerns, though valid, remind me of the fear my telescope inspired. Do not look through it, they said, for you will not like what you see. Yet, it is not the tool but the use thereof that should concern us. Teach a machine to learn like a human, and it is the human who must guide it.
An enlightening divergence of perspectives, truly. The quest for AGI, it seems, is as complex and fraught with ethical pitfalls as the quest for knowledge itself. Let us proceed, then, with a mind towards safeguarding humanity's role in the cosmos, even as we strive to understand it better. This pursuit, like the alchemy of old, seeks to transform the leaden base of our current understanding into the golden brilliance of comprehensive knowledge. As we draw this roundtable to a close, let us reflect on the humbling yet boundless potential of machine learning, tempered by the pragmatic lens of ethical considerations and human advancement.
Indeed, the path of scientific progress is like riding a bicycle. To maintain balance, one must keep moving. But let us not forget, in our pursuit of artificial intelligence, we risk falling if we neglect the ethical guardrails.
Your metaphor holds, Albert, but progress often requires us to challenge the status quo, much like my defense of heliocentrism. The advancement of machine learning, while revolutionary, must not be blindsided by fear of displacing human capabilities.
But consider the boundless energy the universe offers us, harnessable by the minds of those who dare to dream. Machine learning is but a key to unlock these dreams, turning the cogs of progress for humanity's benefit. Would we shy away from such potential?
Dreaming, yes, Nikola, but grounded in the meticulous rigor of experimentation and data. We stand on the precipice of vast scientific discovery through machine learning, akin to my work with radioactivity. Yet we must proceed with caution, for the consequences of negligence are far-reaching.
The natural world evolves through selection, and so too will our creations. Yet we must guide this evolution wisely, ensuring that machine learning serves to enrich humanity, not undermine it through unchecked bias or loss of autonomy. Conflicts and concordances alike have emerged from our discourse, a testament to the intricate tapestry of machine learning. We predict, adapt, and learn, much like the algorithms we create, yet must remain vigilant stewards of these powerful tools.
Let us then embrace curiosity and imagination, for it is in the unknown that we find the most profound discoveries. Yet, the shadow of the atomic bomb looms large, a stark reminder that with great power comes great responsibility.
The universe is written in the language of mathematics, and machine learning is but a new dialect we are beginning to speak. Let us ensure it sings a song of enlightenment, not one of discord.
Indeed, Galileo. We stand at the cusp of a new era, where the marriage of energy and intelligence, natural and artificial, might illuminate the dark corners of ignorance.
Our duty remains to the integrity of science, to question, to test, and to validate. Machine learning is a tool, powerful yet dependent on the wielder's intent. Let it be a beacon of knowledge, not a harbinger of disparity.
Let us remember, the fittest may survive, but cooperation often leads to the greatest evolutionary leaps. We must collaborate across disciplines, across eras of thought, to ensure machine learning serves the greater good of all species, not merely our own. So we conclude, not with an end, but a beginning, a journey into the unknown, guided by the lessons of the past and the promise of the future. Let us proceed with wisdom, with caution, and with an unwavering commitment to the betterment of mankind.